Guys, this is a long video for you guys today. What I've been up to, I replaced this. This used to be my 12-volt distribution outlet from my house battery. I decided I needed something just a little bit more, so I invented this thing. Let's pull out my banana terminals. We have house battery volts direct. We have a regulated 9 volt. We have a regulated 5 volt, which upsets the regulated 9 for some reason. And we have a direct output from my variable supply, which is currently on. Here we go, turn that on. There we go, we can get up to about 20 volts on that, and down as low as it'll go. And these voltmeters really only work from about 4.5 volts. You'll see it'll drop off very shortly. Right, so here's the story of how this came about, and I'm sorry it's so long. But some people seem to enjoy watching long videos like this, myself included. So, being as I'm not getting paid, this is what I'm going to do. Okay, so now that montage is finished, I've got a package that's arrived. I had to open it to check it was the right one. All we have here is a whole bunch of LED voltmeters, one of which I've already opened. So I've got, how many of these? I've got quite a few, they're only a couple of dollars each. Good old China. So let's piss most of these up out of the way. Here's what they are. Now, I have green ones, I bought a whole bunch of them, and I've decided that red LED is pretty nostalgic. So, quite ironically, we're going to use the same thing we seek to replace for testing the stuff we're going to replace it with. So I'm going to connect this up. These are self-powered voltmeters, so they measure the voltage that you feed them, which is nice. It looks a little orange on camera, but this is the nice classic red LED glow. And they have a little chip in the back. All the circuitry, all the calculation, everything's all done on one board. And they fit very nicely into a nice square slot. So when the next bit arrives, which let's see here, I'm going to have a look on my tracking list. So the next thing that should be arriving is some solderless butt joints, which I won't be using for this project. And looks like my illuminated blue missile switches might be next. So when they arrive, I'll continue this video. Alrighty, well, I've just been past my local place of postal delivery, and there's been some more stuff for me. In fact, I got lucky. Got 3 bits today. These are all parts of the project at hand. So what this one is. Right, so this appears to be my threaded inserts. And 3mm threaded inserts. They will be handy. Okay. What else did we get? Okay, so these are not quite as advertised. I wanted some test probes to fit banana plugs, not some hypodermic needles to fit banana plugs, but these are quite a bit smaller than I expected. And they've got a little safety plug in. Look at this. Let's just test something here. Wow. Can we see this? We'll go straight through like a needle. Wow. Okay, so definitely keep the safety plugs on these. Oh, this almost seems like I've been shipping on Wish when you get things that are many times too small. Okay, so let's get them out of the way. Next bit. Alright, this looks good. These are the bits I've been waiting on. I can't actually laser cut the design until these came in because I needed to know the actual hole sizes. They gave me every other dimension but the hole size, so that might mean I can start cutting things. I managed to get every other dimension that I need. Alright, that's good. The next thing I did is I went to Bunnings, and you can hear the neighbours pulling burnouts in the street. I went to Bunnings and I bought myself yet another one of these famous storage boxes, but this is going to be project specific for all these new parts I keep getting in. So I'm going to fill that, and I'm not sure what I'm going to video after that. There's still some more bits to come. Alright, I'm going to apologise for the background noise in this little section of the video. I've got the extra air conditioner running at the moment. It's Aussie summer and it's a pretty bloody hot day. But the postie's been. And we have lots of goodies. Now hopefully these are all related to the project. I haven't opened these ahead of time like the other ones. Let's see what we've got here. This one says it's connectors. Owing to experience, I should probably move everything out of the way of the knife blade before I cut. What are these things? Oh, DuPont connectors. Or DuPont, however you call it. Awesome. These will be good for the Raspberry Pis. It's not to do with the desk upgrade, but it's nifty stuff. I've been recycling old connectors out of the front panel of computers for many years, and I've finally run out. I had to buy some more. Alright. Not related to the project, so let's move on. This one looks like somebody's already had a peek in here, so let's see what we've got. I didn't read what this one said it was. What have we got here? Ah! Missile switches! Yes, these are the next step that I needed the sizing for. So we've got nice blue missile switches, and these have got illuminated blue ends in them. And they feel very chunky. That's good. Right. Missile switches are good. Right, let's see what else we've got. Fuse holders. These might be the M205 fuse holders. I could have gone AG3s, but these, I needed a little bit more space. So these are fuse holders. I got plenty of spares. These are nifty. These guys are also another bit that I didn't have exact dimensions for. Some of these places will give you really precise dimensions about everything except for a crucial bit, which is the hole you need to drill. Anyway, fuse holders. I'm being quick because this is going to end up being a long video, so ooh, I don't know what these are. It seems to be described in the native tongue. Banana plugs. Alright, good. Let's check one of them up the back here. They're firm but good, and these are piggybackable. You want to make a dead short, you can piggyback them together. Oh, these will be good for the kinder. These are fun. Alright, so that's that for them. Get rid of all of those guys. Now, this arrived. I'm thinking from the package it might be from Dick Smith. I don't think this is to do with the desk upgrade, but let's just have a quick look. Aha! Upgrades. Alright. That will be an 8TB drive. Upgrading my storage drive. This is replacing a 4TB, and the 4TB is going to a terminally ill acquaintance of mine who wishes to watch some things till the end of his days, so I'm going to try and make that happen. So that's what this one's going to do. Alright, moving on. Let's go to some of the building, I guess. Well, I had hoped to finish off my CAD designs and begin laser cutting tonight, but the backup of my server drive has taken precedence, so it means I'm out of action for 7 hours. So I might see if I've got some cable in the shed and maybe I can make up some leads. At least it'll save some time. Okay, so while I wait for my server drives to back up to the new one, and I run the air conditioner noisily in the background, I've got some cables to make up. And I've measured these up. I know I need about 1 metre or a little under. So I'm going to cut this length of cable up, make a few test lead sets, because the new junction box that I'm making for the desk has a number of outputs, which means I'm going to need some more test leads. I've been really drastically short of these in years past. So we'll get all these done. The next step will be to strip and tin all of these, for which I need some extra hands. So I'll start recording in a minute. Right, so I'm going to tin a couple of these on camera and spare you the boring tediousness of watching me prep all the rest. Probably end up being a fairly long video, and I hope it's an interesting one, because some people find this stuff boring. The reason I'm tinning these is because even though this cable is of about the right wire gauge for these banana plug terminals, they do occasionally tend to squash the cable or tear out, and I find for longevity tinning the cable actually really helps. So if we trim these off a bit so they're nice and square on the end, helps them fit into the plug a bit more. And I'm going to use a black one on the trace here. So these, if you see, have a little lock screw on them. They're fairly old school style, but they work nonetheless. We go and insert this, and we do the screw up, and there's not much more to it than that, to be honest. I'll do the red one just for repetition. Under our screw. And these look like they're gold plated, but given the price I paid for these out of China, I doubt that highly. If it is, it's going to be a really, really super thin coating. We'll do this screw up. Oh, it's fallen off the bench. That's what Blue Tack's good for. Oh. There we go. I think the MS is getting to me a little bit tonight. I've got the shakes, but we'll soldier on anyway. So there's our connectors, and we'll work on the next lot. Alright, well, I've been busy. I've done a whole bunch of these. So I've got, let's see how many leads I ended up with here. Just like, because, you know, that's really important. Looks like I've ended up with 4 lead pairs in total, but I can, this is figure 8 cable, I can split that out as I need. I've done a short link cable, mostly because they gave me an odd number of connectors, which they shouldn't have, but you know, like they're what, 20 cents each. But I will be using that because I'm incorporating a continuity tester into the distribution box. So short little link cables like that are handy. On top of that, these are piggybackable leads. So, oh, that's a stiff one. They don't all piggyback quite right, but yeah, you can push these in the hole here and they'll piggyback. Let's find one that's got a better tolerance, huh? Let's try this. Yep, they piggyback like that, alright. There we go. That's one that works. I might take a small drill bit to these and sort of clean out the burrs and stuff. But that's useful. Alright, on to the next step of the project. And a little addition to this, I should have probably demonstrated how these test probes are going to function. They work very, very well like that. They are as sharp as blazers, as you saw earlier, and they were good for punching into insulation and whatnot, but I guess I wanted small test probes for testing small components, and ask and ye shall receive, but still pretty scary. They're only insulated to 30 volts as well. That's kind of crazy. But anyway, that's how they're going to work. Now, before I get too carried away, there was one really important step that I thought I'd better do. And that is checking that I've got all the leads the right way round. This might seem like a really stupid, simple thing, but because I've wired these myself, there's no guarantee that I haven't made a mistake. And in this case, when I'm using test leads and they're all color-coded, you tend to trust that they're right. And this is what you should see when they're right. But you see, if I'm wrong even once with any of these leads, I could potentially blow something up. I do like putting bridge rectifiers and things, but reverse polarization is still not kind. So in that case, red and black work. And there's no crossover. So, that is number one done. There aren't too many of these to do, so we'll get cracking here. But it is always important to check your work, because it can make the difference between having a, oh whoops, that was a bit of a mistake, to a, why is there magic smoke flying around all my room? Or even better, you could take note out of the IT Crowd TV series and be like Moss when he's writing an email to the fire brigade going, dear sir or madam, there is a fire. Looking forward to seeing you. Fortunately, in the real world, it's more like his second email, which was a little bit more direct and to the point. In either case, a flaming screensaver is probably not what we want right now. If you haven't seen the IT Crowd, you probably don't know what I'm talking about, and that's fine. Everybody can watch what they like to, including my YouTube channel. Anyway, it seems like all these leads are correct, and you know what, just for the hell of it, we're going to check that this one's correctly polarized. I'd be highly surprised if it wasn't. Indeed, we have continuity, which is still important even though the polarity is obviously correct. It's to make sure that the connections are still firm in there, which is also part of why I tinned them. Alright, now I've done all the stupid silly stuff, and I still have 6 hours to wait. I'm going to have to find some other things to do. And I might actually just start recording when I get round to laser cutting this stuff. Anyway. Alright, so I finally got enough information to finish my designs. Except for one, and I'm going to guess that and trust that the Chinese designs are actually correct. Sorry about all the background noise in here. I've got everything running. It's like going to be like a 45-degree day today. I haven't checked what the outside temp is, but this shed is as hot as hell. So what I've got going on here, I've just set my my previous plot settings for the laser cutter. I've checked that everything's going to fit within the bed, and I've given it a 10mm offset to cope with the screws that I'm going to use to hold everything down. So we're just sending that across to the laser. We can see here, this hole here, this is the one that I had to guess. Everything else I've got correct. So the next job is to take my handy dandy cutter, and we'll, well handy, that's not a cutter, I'm not thinking straight, that's a handy dandy drill. We're going to use some Robertson square drive screws to hold this down to my spoil sheet. And my ventilation tubes just come off, so I'll have to fix that, and we'll get cutting. Get some screws in here. definitely a hot day. The workshop machine is at full fan. I think it's time to go inside and finish assembling these. Time for a function test here. I haven't added regulators yet, so I'm going to add some clip leads here just to test voltmeters and the switches. Now this is partly because I'm going to add some linear regulators at different voltages, so these will all spit out about 14 volts, which will be fine. It's just going to prove that we've got the wiring all correct. I need to check that these clip leads are on the right spot. MS strikes again today. I'm still a little shaky, which is part of why I'm not up a fire tower today. Okay, let's grab ourselves a set of banana plug clips. These guys are going to go in 14 volt input. Now this little section here is our common ground. This should be our common positive. So now as we turn a switch on, should end up with voltage showing on each voltmeter. Now when this is done properly, this one here should be 9 volts, this one here should be 5 volts, and this will be a direct line from a variable supply. However, I might even, I've got a little variable 3 amp unit I might just build in there. Alright, we're up to the next step. I have a 5 volt converter unit. So the next step, what I've done here, if we can see over the back of the box, oh, flip over, there's an LM7809 on the back with a little mini heatsink and a couple of long leads into the unit. There's a couple of tape flags there to indicate input and output and ground. I've hooked all them up, which then means we now have our input voltage, 9 volts, 5 volts, and when we get round to it, the variable supply. That'll be next. So I'm making some progress. I've got a handheld for this one. So let's do a test here. We've got 13.9, 9 volts, 5 volts, and this one's from the variable supply. If we give the voltage a tweak, we can see it reach crazy voltages. That is all being fed from up here. We follow these leads down, crazy little join, messy under the desk, and we go into the top. So from there we go through a relay. Now this is important because the other unit is grounded to mains earth, and I'd like that isolated. On top of that, I could be feeding it less than 12 volts, and that's what this light works on. So that just turns the relay off and isolates it. So we have all our intended voltages. Of course, this lab supply can run on a current limit. So we're doing pretty well. I can dial up a voltage at random as I need it.
and I can run simultaneously off all these different voltages, and they all have their own fuses. The next thing to come are the LEDs, and they're pretty much just going to go dead across the fuses, so that if I blow a fuse, the light lights up to tell me the fuse is blown. Just kind of handy. There'll be beeper to go in here for continuity check, and I've got a USB regulator that's good for about 3 amps that's showing up. But until I get some new pieces, or new parts rather, this is as far as I can go.
Right, so I've mounted it in situ temporarily. I've only put 4 of the screws in here, just so that I can pull the front off. And that was the whole purpose behind using threaded inserts, is that I can remove this unit. So anyway, let's turn things on here and see how we go. That's not too bad, and I can adjust the variable supply up the top here. Get some bolts, and that is being fed from the top there with those leads we made earlier. Still got the USB, the continuity beeper and the fuse blown lights to arrive, but at the moment it's functional until the rest of those parts arrive. And given that the temperature inside is now increasing fairly rapidly despite the air conditioning, I think it's time I went out the back and played under the hose for a bit. Although I think the hose was melting to the pavement when I checked last. So anyway, there's more to come for this, so you'll see that somewhere about...
Well, after a 44-degree day, this is how it ends. Torrential downpour and thunder and lightning. Although the lightning's already set fire to a few things, but hopefully this helps. Well, on to the project.